Okay. Here we go. And then we'll try a few practice steps. So there are two methods. One light off, good. So what? Both? I might fall asleep if there's both. Right now? Should I turn this one on? Fair enough. There are two methods used to balance redox reactions. Two methods, all right? One, the oxidation number change. Two is the half reaction method. We're going to go over both of them here. Okay, so the first one, oxidation number change. Oxidation number change method. It's kind of hard to see up there. That's our first method we're going to try out. Okay? Oh, my light's going to be in the way of this? Oh, I thought that was going to work. So what? I don't know. That it would. It would still like that. I have a good feeling this is going to work. That works. Looks a little funky, but it works. All right. So, balance the following equation. You know what? I really want to write on my board. Hey, Josh, can you do me a favor?
Yeah.
Can you stand up and maybe like angle the projector like to like right here? Man, he doesn't even have to get on like a desk or anything. That's phenomenal. Oh, that's perfect right there, actually. Holy smokes, that was like super fast. Thank you. Okay, so balance the following equation. All right, balance the following here. Okay. Now, step one. Assign oxidation numbers to all atoms. Okay. Step one is assign oxidation to all atoms. I gotta move this now. There we go. Oh, so close. Beautiful. Okay, so let's do that. Let's do that real quick. All right, what is oxygen always in a compound? -2, we got that? I feel like we're pretty confident on that. So -2, that's going to be -2. That's going to be -2. Okay. Now, let's do some easier ones. What's the C going to be here? What's this carbon going to be? 2. Okay. What's an element by itself? What's carbon going to be here if I have 2 -2s? 4. Very good. Okay. We just have one more to do. Okay. Let's see. I have 3 -2s. What's 3 -2s? Okay, -6. So let's talk this out. Total oxygen, I'm going to have -6. What's that mean iron's going to have to be? 6. But I have 2 of them. So what plus what equals 6? 3. 3 plus 3 equals 6. So iron here is 3. Okay, we got all our oxidation numbers done. Yes? Once Nathan gets back. Okay. Oh, we nailed this. That was pretty cool. Okay, did that. Step 2. Identify which atoms are being oxidized and reduced. I feel like we kind of already learned like the step 1 and 2. Okay, so what is being oxidized? What is being reduced? Anybody got a guess? Yeah, Dawson.
What's Fe again?
Iron.
Iron's being reduced.
Iron's being reduced from 3 to 0. Very good. All right, what's being oxidized? Somebody else. C? C's being oxidized because it changes from 2 to 4. You're exactly correct. You guys see that? That's step 2. We did step 1 and step 2 already. Holy smokes. Whoa, 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 whoa. That's pretty fun. I could watch that for a while. Okay? All right, so we know iron is going down 3. We know carbon went up 2, right? We see that, we got that, we're good to go. Now, step 3. Step 3. Let me erase this now. This is a longer one. Make the total increase in oxidation number equal the total decrease in oxidation number by using appropriate coefficients on the reactant side only. Okay. Make the total increase to equal the total decrease. Okay. Let's check this out. What flavor you got today? Oh, fruit punch? That's a good one. I like the banana strawberry one. Oh yeah, that's pretty good. Or the tropical punch. You like the yellow ones?
I like orange mango.
Orange mango. I'll have to try orange mango. Okay, so we said iron loses 3. Is that correct? That loses 3. We said carbon goes from 2 to a 4. That gains 2, right? But if we look right now, I have 2 irons right there, correct? So instead of losing 3, how much does this one lose right here? I have 2 of them. It loses 6, right? So right now, this loses 6 electrons. Okay? Right here, I only have 1 carbon. So I only gain 2. I only go up 2. Right? I should say loses. I'll just say loses 6. Okay? I only gain 2. So what must, if this loses 6, I have to gain 6 down here. I have to gain 6. So what do I have to multiply this bottom part by? 3. I have to multiply by 3. Because 2 times 3 is 6, right? So I'm going to have to put a 3 there. So on the bottom part, I have 6. On the top part, I have 6. And the reason I had 6 on the top is because I had a 2 here. I have to multiply that by 2. Okay. Does that kind of make sense? Getting a lot of sleepy eyes. Do we need to stand up?
No, we need a break.
We need a break. This is only the first method.
Yeah. Need a break.
Okay. So, let's see what we got. What's this tell us? Okay. We gained 6 electrons, lost 6 electrons. Perfect. Got a 3 there. Perfect. Okay. Now, finally check to make sure the equation is balanced both for atoms and charge. Well, we know charge is balanced. What about atoms? How many irons do you have here? Two. So you got to put a 2 there. Okay. That makes sense. Let's see. How many carbons do you have there? 3. So what if I put a 3 there? If you have 3 carbons there, you got to have 3 carbons there. And you're done. That's one method. That's one method. Okay, 4 steps. That's not too bad. 4 steps. Okay? Not too bad. Make the total increase in oxidation number equal the total decrease. That's pretty clever. That's a clever way. Okay? We like this way. We like this way. The second way gets a little extensive. You good? Anybody writing still? Okay. The second method is using half reactions. Okay? We're talking about a half reaction. Okay? And this is the extensive one. There's a lot of steps. And if you want to write it out, awesome. Can I offer a suggestion though? Maybe take a picture of it. There's a lot of steps that's going to be popping up here. I would take a picture of that if I were you. And if you don't have a picture, I'll be posting this to Google Classroom. Okay. So, first, split the original equation into a reduction and an oxidation. And then you have to balance. Okay? And I'm going to go over an example here. Do you guys have a picture of that taken? Everybody good? Okay. We're going to go over an example because there's a lot of steps to this. Okay? There's a lot of steps. And honestly, I have my own picture of it because there's a lot of steps. I don't have all the steps memorized. So I don't know. I'm going to write it on the board. Fe. Oh, that's not what I meant to write. Fe with a +2 charge plus Cr2O7 with a -2 charge. Fe3 plus Cr +3. Okay. Here we go. So let's try this out. Step one. Step one says, if you have that picture out in front of you, step one says, first split the original equation into 2 half reactions. One of them's reduction, one of them's oxidation. Well, do we know what's being oxidized or reduced right now? Do we know? Like, can we do it in our head? Which one's being oxidized right now? Anybody got a guess? Yeah. Fe, it goes from a 2 to a 3, right? So we know Fe is being oxidized. So my oxidized reaction is Fe from +2 to Fe +3. That's what's being oxidized. There's one half reaction. So the other ones have to be reduction, right? I'm going to write these in black. So the other one has to be reduction. So what's left? We already got that. So all that's left is Cr2O7 with the -2 charge creates Cr plus 3. So we got that. We got that. Does that make sense? We know it was reduced. We know it was oxidized. Okay. I'm just going to erase this. We don't need that anymore. How close that? Okay. Oxidized reduction. Now, let's see. We did step 1. Step 2 says balance all the elements, bless you, except for hydrogen and oxygen. Balance all the elements. Well, let's do that. How many irons do I have?
2, 4, 6.
How many irons are right here? I have 1 of them. With the one has a 2 charge. How many irons do I have here? 1. This is balanced. I have 1 and 1. Okay, let's go to the bottom one. Chromium. How many do I have there? How many do I have here? 1. So I gotta put a big old 2 right there to double that. Does that make sense? So they're balanced. That's step 2. I just nailed step 2. Let's see. Step 3 on our picture. Balance the O's by adding water. Balance the oxygen by adding water. This is step 3. Is there any oxygen up here? No. Is there any oxygen down here? Yes. So how many oxygens do I have? 7. So I have to balance that by adding water. So that means on this side, how much water am I going to have? Well, let me write out water. Water is known as H2O. So if I have 7 O's over here, what number has to go in front of my water? 7. Does that make sense? Because that gives me 7 O's. And over here, I had 7 O's. Guys, we're kind of cruising through this. That's step 3. Step 4. Everybody good so far? Step 4 says balance the H's by adding H plus ions. Okay. Is there any H's right here?
No.
Okay. Is there any H's down here? How many? Oh, be careful.
No.
How many H's do I have here?
14.
14. I have 14. So I have 14 on this side, which means I have to add 14 to that side, right? So I'm going to add 14 H plus ions. Does that make sense? H's, balance H's. That's step 4. Okay. Let's see. Step 5, or if your reaction takes place in a basic solution, proceed to step 5. If your reaction takes place in an acid, proceed to step 8. This one is an acid. So let's go to step 8. That's pretty awesome. And I'll tell you if it's acid or base. So that's pretty awesome. Balance the charges by adding electrons. Oh, let's do that. Okay. So I have to add electrons. What's an electron? What charge does it have?
No. Neutral. No. Negative.
Negative. All right, so I have to add a negative. So, for example, I'm going to add an electron there. So what is 3 minus a 1? 2. 3 minus 1 is 2. Okay, let's see here. This one's tricky. This one's tricky. How many pluses do I have here? 14. I have 14, positive 14 there. How many negative 2's do I have right here? 1. Okay, so I have a negative 2 there. How many positives do I have here? 2 positive 3's, which makes it positive 6. Okay, and is there a charge to water? No, it's just neutral. I don't care about that. So what's 14 minus 2? 12. 14 minus 2 is 12. So I have to add electrons. This time, I'm going to add electrons to this side. Why? The negative, right? So I have to add 6 electrons to that side. Because 12 minus 6 is 6. Okay. There we go. This is a big one. Let's see. What's my last step say? Recombine the half reactions into a complete balanced equation. Okay. So let's do it. Let's do it. So all my reactants are going to be combined. Okay, all my reactants are going to be combined. So I'm going to add Fe to this bottom side, right? The reactant side. So let's do that. I'm going to add Fe plus 2 to this side. And I'm going to add Fe plus 3 and an electron to that side. Does that make sense? We have one big reaction. One big reaction now. Okay. The very, very last thing is everything balanced? Everything does look pretty balanced. How do we feel on that? Pretty tricky. Pretty tricky. If you want to even go further, you could imbalance the electrons. That's up to you, though. But what I want you guys to do is grab, from last week, we had a paper that looked like this. All right? And I said we're going to hold on to it for probably Monday, Tuesday, maybe next Wednesday. Today's the day. Today's the day. It looks something like this. All right? Now, we are going to try number 16. I think we got enough time for 16A. We're going to try 16A today. Right, just one of them. Yeah. Let's get you this paper.
When do you hang it up?
I don't know. That's a great question. I might have handed out Thursday. That's a possibility. Last Wednesday. I do have extras though. A pencil, absolutely. All right. So try to get a head start. We're just doing 16A. 16A. Was it not sharp?
No, sure.
Oh. Oh, I ran out of tissues. I do have paper towels though.
that's just a no. That's just
Sorry.
paper towels. They burn.
I use paper towels.
It's really.
If you want to go to the restroom and use toilet paper, that's fine. It's up to you.
We'll finish this.
All right. So guys, try to get a head start. I will slowly